Okay, welcome to today's lesson, which is looking at the area of similar shapes. which is looking at the area of similar shapes. Let's just look at a simple area question. To find the area of this small rectangle here, we do, let's put that into centimeters. We do 5 centimeters times 3 centimeters, and that gives us an area of 15 centimeters, 15 square centimeters. Now, if we look at this rectangle here, it's clearly double in size, i.e. the lengths have increased by 2. So this length is 10 centimeters and this length is 6 centimeters. So has the area doubled? Well, let's check it out. So the area is 10 centimeters times 6 centimeters, which is 60 square centimeters. So in fact, the area hasn't doubled. In fact, the area has gone up by a factor of 4. Now, let's see why that's worked. If we consider this area again, it's 6 centimeters times 10 centimeters. I'm going to split the 6 centimeters into 3 times 2, and the 10 into 5 times 2. And if we just take the 3 times the 5, that was the area of the original rectangle, which is 15 square centimeters. And then we multiply by 2 times 2. Now, remembering that 2 was the multiplying factor for the length, and we do that again here. And so it's 15 square centimeters times 4, which gives us the 60 square centimeters. So in fact, the area has gone up by a factor of 4, and that factor of 4 comes from the multiplying factor for the length squared. Here I've drawn 2 similar shapes, and in fact I've doubled this shape here. If we consider each square to be 1 square centimeter, then the area of this shape is 5 square centimeters. And what's the area of the new shape? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So the area is 20 square centimeters. Again, we've doubled the lengths, but in fact the area goes up by a factor of that scale factor squared, i.e. 4. So 5 times 4 gives us the 20 square centimeters. Excuse me. Typically, the questions we see on tests involve triangles. Okay, we can work out the area of this triangle here. If you remember, it's base times height divided by 2, and the base is 5, the height is 4, and divide that by 2. 5 times 4 is 20, 20 divided by 2, and so the area of this first triangle is 10 square centimeters. Okay, now let's have a look. These triangles are similar, and in fact, excuse me, in fact, the multiplying factor is 3. We've lengthened each length by 3. So I think I should be able to predict the area of this triangle, because I think it's going to be 10 square centimeters, that's that area there, times, now the multiplying factor is 3, and we want to find the new area, so we square that. So it's 10 square centimeters times 9, which is 90 square centimeters. So that's what I think the answer is. I can actually check that with the formula. So it's base times height over 2. The base is 15, the height is 12, and we divide by 2. 12 divided by 2 is 6. 15 times 6 is 90. So in fact, it worked. These two shapes are similar. Now they're circles, and the radius has been doubled. Let's see how that affects the area. So the area of a circle is given by the formula pi r squared. So the area is pi times 3 squared, which is 9 pi, and I'm going to leave it in terms of pi. Well, let's have a look at this area here, again using pi r squared. Pi times 6 squared, which is 36 pi. Now notice that 9 times 2 squared is 9 times 4, and that is 36. And so we could have predicted the area of the new circle by just multiplying the old area by 4 to give us 36 pi.